Hello, everyone, and welcome to the AQUALIS Sustainable Water Compliance Summit session, Green Infrastructure Planning, Implementation, and Maintenance Program for a Needs-Based Approach. I am Katie Johns, Editor-in-Chief of Stormwater Solutions, and I will be your moderator for this session. To begin, let me explain how you can participate in this session. First, if you have any technical difficulties during this session, please put your question in the questions window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many as we can during the Q&A after Carrie's presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the Ask a Question window on the side of your screen and hit Submit. Also, please be aware that today's event is being recorded and you'll be notified by email when the archive is available. At the conclusion of the webinar, you will receive an email with a link to download your certificate, which can be used to submit for credit with Stormwater University or serve as one personal development hour for attending today's webinar. Certificates will be sent to attendees who viewed this session for a minimum of 50 minutes, 50 minutes. For those viewing this session on demand, you will need to complete and pass a short quiz at the end of the session to receive your certificate link. And now let me introduce you to our speaker, Carrie Bristol-Grohl, who is Executive Vice President of Engineering Services at AQUALIS. Carrie received a bachelor's degree in civil engineering from the University of Wisconsin-Milwaukee and has been working in the field of stormwater engineering since 1994. Carrie began her career as a stormwater engineer for the cities of Milwaukee and Brookfield prior to founding Stormwater Solutions Engineering in 2002. SSE is located at the Global Water Center in Milwaukee and has a team of 10 professionals designing stormwater, green infrastructure, water quality, and flood control practices for municipal, transportation, water agency, and private clients. Carrie is also the inventor and owner of the patented rainwater harvesting device, Storm Garden. Carrie has been involved in volunteer activities for many local groups, including Engineers Without Borders, Milwaukee Riverkeeper, Future Cities Competition, Science Fair Judging, UWM Alumni Efforts, the Wisconsin Sea Grant, American Council of Engineering Companies, and others. So with that, it's all yours, Carrie.
Thank you, Katie. That was a pretty long introduction. There's only one thing that I think may have been needing a little update, and I'll get to that in 1 second. But good afternoon, everybody, and thank you for joining us. There's been really great speakers all day. I've been listening in, and I couldn't have really picked some of the speakers to be any better introductions to what I have to present to you than what the AQUALIS team did with the ramp up. And I don't think they did it for my benefit, but you'll see why in a few minutes. First, I wanted to mention something that Katie said. Stormwater Solutions Engineering was a company that I owned and founded and owned for 21 years. We became a part of the AQUALIS team a year ago. So why I wanted to show this one little marketing slide, only one, but very briefly, is so that you understand that AQUALIS is not just the company that is doing the field work, the stormwater maintenance, restoration, stormwater repair, and things like that in the field, but we also have an engineering division. That's pretty much indicated by the left column of those services that are shown there. And part of those services is what I'm going to be talking with you about today. So Green Bay, Wisconsin, I wish I could get a show of hands of who knows Green Bay, Wisconsin, or who even knows Wisconsin, who's on the call. But I'll give you a little bit of an overview of who these folks are. This is a small community of 107,000 population. The whole metro area is about 380,000. So the city itself is not quite that large, but what's interesting about that is that Lambeau Field, where the Green Bay Packers play, almost doubles the city's population in that one game or that one day or 2 days or so around the game time. So an interesting thing about that is that when you're thinking about infrastructure, whether it's gray or green, you need to be designing for the potential full size of your community, and that would be looking at, beefing up all of the roadways, all of the gray infrastructure to handle this larger population. And while they're doing that, the city is thinking, like everyone else, maybe we should consider green infrastructure in various places throughout our city. They are dealing, they're located, the Bay of Green Bay is that sort of space between the thumb and the hand, if you would think of that as Wisconsin. Lake Michigan is off to the right side there on the screen. And that bay has a lot of issues, as you would expect on any coastal water, and this is a freshwater coast. They are a municipally separated storm sewer system, so they do have a DNR permit, like many other communities, for TMDL. And I'm putting a lot of these acronyms on the screen so that if you've been hearing them all day, at least you get to see actually what the definitions are. They're required to manage total suspended solids and total phosphorus as a part of that permit. The waterways are DOD 303D listed waterways. So the Fox River that runs right into the Bay of Green Bay is a 303 listed waterway. And there are CAFOs, which I didn't draw this one out, but concentrated animal feed organizations in that watershed. So we have a lot of dairies in Wisconsin, you might expect, with being a cheese state. We also have some non-CAFO agriculture that's going on, and a lot of runoff from these agricultural areas contributing to that same water body as all of the urban runoff. There's coastal flooding with very fluctuating lake levels depending on rainfalls throughout a couple of years. We've had a historic high and low water elevation in the Bay of Green Bay within a 4-year period of time, with a 4-foot change in elevation. So you can imagine, if you're getting used to a water elevation at 4 feet lower, and all of a sudden it's rising up, and then we get some storms, we're going to see a lot of coastal flooding. I'll tell you why that matters in a little bit yet. And then also area or annual rainfall increasing in Wisconsin, as it is in various places throughout this country and the world, really changing and, pointing fingers at climate change or at just changing weather patterns, somewhere between 33 to now 38 inches per year on average. So a lot of communities are saying, maybe we should think about green infrastructure. We heard today from Lisa Haney starting off, and how we did a really good job thinking about point sources for sanitary outfalls and for point sources that were coming right off of industry in the old days, and where stormwater is now the #1 reason for pollution in our water bodies. We need to do more with source control, and that's really what green infrastructure is. We describe that as managing water where it falls. Grab it as close to the source and do something that holds it, allows infiltration, allows settling of pollutants, and maybe it's going to be a temporary holding place until that storm has passed, but it's a way to consider multiple areas of storage throughout your watershed. We also heard quite a lot from Matt Prusko, and I really appreciated all of his design insights. We've seen so many of the same things. We've been designing green infrastructure for about 20 years, and in Wisconsin, and you can hear my accent, you'd think, northern climate and frozen conditions and those things all don't seem to be really great matches with green infrastructure, but we've worked through all that, and we've got a lot of very similar lessons that we've learned from that. But he talked about managing a lot of smaller storms, because it's the most often storms you're going to be seeing, so the 1 to 2 inch storms, or even less than 1 inch storms. And I want to address that a little bit too, and some of the things that we've talked about with this project and where we maybe changed that just a bit. He added some awesome examples of bringing agencies together and various communities and groups and people to have great things happen within your watershed. And I think all of that is key. And if you're listening now to go, all right, so this is a lot of good tips, but where do we start? How do we get moving on that? That's what this plan is about. So the city of Green Bay wanted to add a porous pavement roadway. Maybe they received a grant, they had some active construction projects coming, and they wanted to bring this to their common council. And the council said, that's all well and good, but if we're going to consider spending money on this, we want to know where is the best placement. We just don't want to, throw it randomly wherever we have open space, but let's plan out strategically where we want it, why we want it there, how we're going to pay for it, how we're going to maintain it, how do we get the most bang for our buck, so that we don't have a lot of residents coming forward and complaining that really we're wasting our public dollars. So they wanted to provide steps toward flood and climate resiliency and water quality, guide the identification and tracking of GSI, they call it green stormwater infrastructure. I'll jump back and forth between GSI and GI, green infrastructure, so that you know with that. I'm not talking about a gastrointestinal issue, it's green infrastructure. reducing flood risk where we can and provide water quality for that TMDL. Then prioritize an actionable list of GSI projects. So, you know, a lot of plans go on a shelf that give you a lot of great information. Other GI plans that we've done have said it's a good idea to use GI. These are the great reasons. These are the co-benefits. This is why we might want to do it. But where do you actually go with it? Where do you get started? Who does the first, you know, shovel in the ground to move it along? And that's what they wanted this plan to do. So a ton of credit goes out to the City of Green Bay and Melissa Schmitz. I'm showing her name here. She's the resiliency coordinator at the city, and she really had a good mental image of what she wanted to see at the end of this project. Then create a process and a framework to implement everything. Ensure that this plan ties in with other GSI programs and goals. They have a revolving loan program for their residents that if someone wants to install a rain garden or something bigger than a rain barrel, something that will cost a little more money than that, perhaps porous pavement along their driveway at the sidewalk edge or something, so they can get a very low interest revolving loan from the city. And they wanted this plan to tie also into that. So determine where the best spend is for those revolving loans in the community and make sure that it all ties together. So I will just jump through this slide because we're going to talk about each one of these items, but you can read them on the screen. And so as we go forward, we'll talk about how did we start this process, what was the output, and what do each of these deliverables look like. First thing, most important, probably most important thing, and I think it gets back to the presentation earlier from Matt, is bringing in all the possible stakeholders you possibly can to talk about why do we want this? Why does this matter? Where should we put it? How should we be using it? Who's going to maintain it? You know, all the questions need to come out. And everybody from the mayor, everyone was involved in this process. The mayor was at our stakeholder meeting for 3 hours. Older people were at this meeting. It was a very well-involved workshop. And I think that's really important. It's not a lip service. It's not, you know, you guys go over there and you take care of that. The mayor was interested in making sure that this was going to happen the way he wanted to see things happen. And he's the kind of mayor that has been reported in the newspaper of helping people move out the flood damaged items from their basement when they had a flood in their neighborhood. So he is involved in the community. A part of that workshop, that kickoff meeting with the stakeholders, was to decide what is green infrastructure and how do you describe this in your community? There are many different types and devices that could be used, and we want to be sure to define what that looks like for the city. And so we showed them many options. And what they came up with was this list on this page here: bioswales or bioretention, green roofs, greenways, which is tying together a variety of green aspects, maybe within a corridor of a park, native landscaping, permeable pavement, rain gardens, rainwater catchment, which would be rain barrel, cistern, storm garden, anything that catches and holds underground storage, even they consider it to be green infrastructure. That's something that can be controversial. If it is, you know, a big structure that goes underground, it doesn't necessarily look green, but why they consider it to be green infrastructure is because, again, it holds storage close to the source. It manages water in small catchments throughout your watershed and allows for settling of pollutants and also not flooding, potentially not overwhelming a sanitary system if there were possibility to be inflow and infiltration happening. We also included removal of pavement and structures as a green infrastructure practice. You don't get as much credit or as many gallons of storage out of this activity, but if you have giant parking lots for big malls that maybe are not being utilized very often, removing that pavement, removing an old building from the back 40 of a school property or something is also considered green infrastructure in this community. Adding soil amendments. We've heard a lot lately about urban soil health, about soil amendments being added and different treatments to be utilized with urban soils. So soil amendments is a very important part of that. These are alphabetically listed, not in order of importance. So, trees also, any type of tree can be added and has some various types of contributions to water quality and all the other co-benefits for air quality and habitat and all these things. And then lastly, constructed stormwater wetlands. Not necessarily just a wetland, but a wetland that's designed specifically for managing stormwater. So next part of our workshop, and we started with a few surveys to all of those participants, is to get a feel for where they are in terms of if you are going to do green stormwater infrastructure or green infrastructure, where do you want to place it? And then what is the need for having it? So it was two different surveys. One is about what is the need for it, and the other is where would you place it? And so when we go through the conversation at our workshop, we talk about, do you want to have green infrastructure only at an outfall of a storm sewer? It's probably not effective there, but some people thought in the beginning, and that's the part that really varied the most with the survey, is a lot of people thought, oh, sure, the water comes down the pipe or down the street, we're going to throw it into porous pavement or a bioswale, and then it will just discharge out to the waterway. And they found out through our conversation that really is not that effective and may be okay for the water body itself, but it doesn't meet a bunch of our other objectives that we'll get to in a minute here. Where do we also want to think about placing it near schools where there's an educational opportunity, only in public rights of way, only on parks and playgrounds? So a variety of locations for where you would want to place it, but then where is the need? And as we had our conversation, it became clear that the highest needs are where there is flood potential or ponding in a roadway. Usually we're not going to be looking at managing coastal flooding. That's just too big a beast with too many potentials for not really managing that well. But where maybe there is an undersized storm sewer and a roadway is ponding every storm, or possibly there's some surcharging happening from a river elevation that is high, causing a capacity issue with the storm sewer. There we might want to place that as well. So we're looking at where we could place it, which would reduce flooding, reduce ponding, reduce water in the roadways or in backyards or that kind of thing. Also, where we could get better water quality for the stream, better stormwater runoff quality, but also improve water quality for in the stream itself. And then, you can see on the slide, which is very tiny, about 6 or 7 other options of where, if they needed to place it, where would they place it? And again, we did this at the beginning and the end of our conversations with everyone, and the opinions did change as we saw a little education taking place as part of that. So the big part of this project really came down to a GIS exercise, Geographical Information System exercise, in looking at taking all those criteria that the city had said were important, where there's ponding, where there's poor water quality, where there's new development planned, where there are right-of-way projects or the capital improvement program projects coming, are kind of like the top items to be looking at. And then where do we have barriers to green infrastructure? Maybe we have high groundwater, high bedrock, sloping areas that wouldn't be conducive to holding water in a flat space. It's a little too much slope. A couple other areas where maybe there was historic rivers that have been installed now into storm sewers, but there's going to be a lot of groundwater that's going to come into play. So a couple of barriers that we wanted to map in GIS, as well as those opportunity areas. So what you see on the screen here is the every sewer shed for the storm sewer system has been modeled with a program here in Wisconsin that's called WinSlam, and it's for water quality. So we look at total suspended solids and phosphorus, and we say, what are the worst areas in terms of the runoff and phosphorus and solids in that runoff? So the blacker, darker the sub-watersheds or sub-sewer sheds are on the map, the more trouble they are for water quality. Those are all inputted into this giant map for the whole city. And we're getting down to very tiny, block by block evaluation. Sometimes those evaluations have been done already as a part of your MS4 permit, and sometimes they're not. So on occasion, then we'll have to do all the calculating to come up with that water quality. Those are mapped. Next, we do take that same map and then we lay those neighborhoods over. So each neighborhood is delineated and it's got an identifier. And the city was curious if they did have that revolving loan fund going out to the community for a rain garden in a residential property, we want to give them a little extra bonus points to their application if they happen to be located in a neighborhood that has poor water quality or that has maybe reduced property values. We also looked at that in the community, hoping we could improve property value by way of more green in that community. So to be able to map where they are, we wanted to have the neighborhood shown. And then historic ponding, I'm going to say more so than flooding. We're not looking at coastal flooding. We're not looking at FIS maps. We're looking at areas within the system where it's usually a low point mid-block or a storm sewer's undersized. You know, storm sewers are only designed for maybe a 10-year storm 50 years ago. Now that 10-year storm is more like the 5 to 7-year storm today. And so occasionally you're going to see, you know, ponding, flooding, water overtopping the roadway into private property. And wherever that happens, they usually get a phone call during a rain event to the police or fire department, and they map these. So they've kept track of all those phone calls they've received. We mapped those and we said, in the areas where the blue dots are, is where you're usually getting the phone calls, which sub-watersheds are those in? Then we're able to lay those into the map as well. So you see where I'm going. We're mapping, we're mapping, we're mapping. We bring all those maps together and it's kind of like making a batch of cookies to see what are we going to get out of it. We're also looking at the city's capital improvement program. So what are the projects that they are going to have on their books for the next 5 years? I think it was a 5-year plan. And let's lay them out. So every location where you see a yellow dot, it's a programmed project. And we're mostly looking at something like a water main, a sewer project, a roadway replacement, you know, something that's definitely in the roadway right of way. I don't believe I have a map on this last bit here, but then we're going to look at constraints. So, well, a positive opportunity or constraint. So an opportunity would be parcels that are in lower than average property value neighborhoods. These are areas that have declined. Maybe they have some amount of vacancies in properties or abandoned buildings that need to be renovated or that need some kind of facelift. We want to try to bring any public dollars we can to try to, you know, bring more life back into these neighborhoods. So we have those mapped. Anything that we have as proposed development areas, we know there's a lot of old infrastructure in Green Bay. It's a very old city. And, you know, so there's some old industry buildings or old commercial buildings that have been sitting vacant that are getting fresh and ready for some kind of renovation. Those are mapped as well. And then we're looking at the constraints. Like I mentioned before, we have a lot of clay soils. We also have sandy soils. So we want to see which areas have clay and which have sand to encourage more toward the sandy side, get more infiltration and groundwater recharge, which have high groundwater. Where do we have high bedrock? And where do we have slopes that are difficult to manage? So we put all these things together, kind of turn the button or push the button, and we see what pops out in terms of the best locations. The city had wanted 50 project sites, 50 of the best locations when we look at all of these aspects. That would be, if we are going to spend money on this, where do we want to get started? Give us 50 locations, 30 in the public right of way, 20 on private property where there is proposed development. So that's what we did. We have a whole team of staff that chugged through this information and came up with the locations that they felt were really best for this. They went through the water quality evaluation, some hydrology calculations, and really wanted to look at how much water can we capture at a certain location, what water quality can we get from that location, do we get how many gallons. We want to talk about gallons of water stored or captured for the public to better understand. We're not doing acre feet or you know, cubic feet or something that they don't really quite visualize. So we're going to talk about how many gallons can we capture at each of these sites, phosphorus and total suspended solids removed. Let's come up with a cost estimate based on current construction prices, which really has changed over the last few years. What construction prices are we seeing, and trying to estimate what that construction budget should be. And then as well as an anticipated maintenance cost for that GI device. So all of that is determined on each site. We produced a sheet like this, a couple sheets like this on each project. And then we really drilled down. So this is still concept level. We only know like utilities based upon aerial photos or some of the city's GIS information. So we're not doing a really deep dive of potholing for utilities or ground penetrating radar for utilities or anything like that. But we are looking at where do we see water main. Wisconsin State Code requires that you have used to be 8-foot separation horizontally from water main. We were really active in getting them to change that code down to at least 3 feet so that we can have a little bit of room in there. But where do we see other utilities? Where's their lighting and all these things? So you can see quite a lot just using a GIS. Then we determined the size that it should be for the area of capture, come up with a cost estimate. And when I mentioned sizing it for a 1-inch, a 2-inch storm, a 1-year storm event, maybe, we actually looked at where we have problems with ponding or flooding or structure flooding within the upper half or third of a sub-watershed. We want to look at trying to make that as large as we possibly can to actually give us a little bit of flood storage as well. We're already in the ground. We're already excavating. If we can get a little bit more width or a little more depth in our underground storage section, you know, the opportunity is there and the cost is not that much greater to make that volume much larger and help to offset that flooding. So that's where we maybe vary a little bit in thinking about green infrastructure is not just a water quality device, but also managing a little bit of those flood flows to do, you know, kind of going back to what Lisa said, and managing point sources and managing water where it falls. And then we pull all that together into a GIS map. So anyone at the city or the public who has access to this map is able to, you know, drill down and find out where we're proposing the various types of GI and then see the details from all the sheets that I showed previously of location, cost, gallons stored, water quality, you know, total solids removed and all that goes into the GIS, as well as what is the anticipated future maintenance? What does that schedule look like? How often does somebody need to be out there looking at it after it's built? And then a place for the city to plan on inserting all that information later. So I've worked previously at 2 cities for the first 12 years of my career, way back, you know, 30 years ago when stormwater management was really just a new thing, you know, in most cities. And to keep a place, a record of where all these things are being installed and who has a maintenance agreement and who's abiding by it and who's been doing a recertification or not. I mean, there's just a ton of information for staff to be able to watch over and to, you know, turn back the times and have hindsight be 2020, like one location to store all that data and to see when something needs maintenance, that you have it on a schedule and that photos can be inserted right into the GIS of the last inspection, the last maintenance, the last whatever was done, really gives them an upper hand in moving forward. And this to me is kind of the secret in if you are planning something going forward, get on top of it and spend a few extra dollars now to make sure that you're going to give your staff a much easier time going forward. And you could be a municipality, or you just could be a large, you know, commercial entity with a few locations that you have a number of assets to manage. Just get a handle on it right up front to be able to have one person take a look at it and manage it and not a whole staff. I think at one municipality I worked for, we had about 10 municipal engineers all working on stormwater. And that's a ton of money over many years that maybe could have been reduced right away. So drilling in on that GIS a little, and we didn't have this interactive for today because of the issues of bouncing out into an interactive screen and back and forth. So I'm just doing a few screenshots, but I did zoom into one of these neighborhoods. And we can see the details. If you clicked on one of those white squares, you would see that these are bioswales and that they're in the city's right-of-way. There is a drainage area collected of 171,000 8,000 square feet. And on my screen, this is really tiny. So I hope if you're interested, you get a copy of the PowerPoint, the PDF that we provide for you, and then you can look a little closer. But we're also saying, what is the number of pounds of total suspended solids reduced every single year? 1.6 pounds every year. Total suspended solids, 643 pounds every year. That's a few large people worth of solids going into these bioswales, keeping it out of the rivers, out of the, substrate of those streams where we're hoping that fish are spawning and all that, instead of being caught into the bioswale. That tells you we're going to have some maintenance of the bioswale as well. But the fact that we're capturing it, going back to a previous presenter talking about trash in the bioswales, I'm hoping that it's going there because otherwise it's going in the water body. So it's really, I look at it when I see that, a bunch of trash and things in the bioswale, I'm like, that it's doing its job. That's what it should be doing. Matt's really good point earlier in his presentation was place a trash can right next to that bioswale, and then we can pick up the trash and put it in. There's a lot of well-meaning neighbors that probably will jump in there and pick up the trash and throw it in the bin if it's nearby. So that is a super good piece of advice I'm taking forward to try to do that on our future projects as well. So back to this GIS, we also see things that you can see on the right part of the screen that have no information. The maintenance type, the frequency, when the project gets implemented. It currently is not in progress because this is not a part of the CIP for maybe a couple of years. So all that information can be kept right here. And then we'll link this to a few slides down from now. We'll talk about maintenance and how we put that information in. I wish I could ask if anybody had questions, but we'll keep going. So triple bottom line, everyone wants to know what are we getting out of this? And you might have seen a slide a few slides back about what was the construction budget, what was the construction value in current present value terms to install these 50 GI devices across the city. And it was actually $20 million in current value, today's current value. So $20 million spent on all of these things. What are we getting for our dollar? And typically you hear people say, it's a lot of fluff. It's a lot of, not very concrete, evidential benefit that you're getting out. Thankfully, the folks at the Water Research Foundation created this very deep, I'll say deep spreadsheet tool that gets into 12 or 13 different aspects of the benefits you take out of green infrastructure. This takes a lot of time for someone on your staff to go through and enter very local specific data of things like cost information on installations, costs of your water, per gallon of use, power, various things that are very local. And once this is all done and, push the button and the little overview screen that you see there says that we get a benefit of all of that $20 million we put in, we get a benefit of $106 million coming out. So that's, even if it's off by a factor, it's still a 5 times return on that initial investment. And that is in improved water quality, not needing to necessarily increase sizes of storm sewers so that you can save people from flooding. We have, reduced temperatures that maybe are helping with some energy costs. If there's a green roof component, maybe being able to reduce costs of energy in the building, just many, many different factors that go into this. I highly recommend joining the Water Research Foundation. It's a membership-based group, but then you get access to their tools. If you have someone in your community saying, we don't believe there's really any, it's all just a bunch of fluff, this tool is very helpful. This was very important when bringing this information to the city council and getting the plan approved and moving forward, that they could see this and bring this to their constituents. When I worked for a few municipalities, and I don't know if it's still the same today, I feel like the old stormwater lady. It was always like, well, we'll have to hire consultants to do these great things because they're the only ones who know this stuff. And, the municipal staff was kind of felt like they were second best to the consultant staff. And that doesn't feel right if you're going to be working there. And we wanted to be able to give the staff all the tools they need to be able to design their own, cool green infrastructure. As a civil engineer, this is the coolest stuff we're going to be doing. This is like more cutting edge. This is more exciting. And we want to be able to share that with everyone. So we gave them the tools to be able to march through a process of how do you evaluate whether this is a good location for this type of device. So we created a few spreadsheet tools. They're not glamorous, but they're just tools, and ask questions about a project schedule. If it's constructed, if it's to be constructed sometime out in the future where they have time to do the design, do they have budget to be funding the installation? Is the roadway designer on board with doing this kind of design? If you have an old school roadway designer, they may be really difficult to deal with. Do you have all the necessary staff on hand? So a lot of really in the office questions about whether or not there is a potential for moving forward on a particular project. And then at the end of this, we give you a little score. And we say, if your score is over 70%, you have a good likelihood of success for this project. If you're less than, if you're between 60 and 70, maybe you need a little extra effort. Maybe you need a champion in the office who is going to push this forward. If you're over 70%, you're probably in a good spot. And this, again, is for evaluating projects that are not the ones that we've already prescribed, but next year a new roadway gets put on the CIP and they want to take a look at whether or not there's a good place. One of the questions is also, does it fall within areas that are constraints like high bedrock or high groundwater? Or does it also fall within one of the areas of poor water quality or continuous flooding? So then we give them a pretty simple little example of, if they're going to do green infrastructure, what is the surface area that they're working with? Is it roadway? Is it a parking area? Is it a park, a school? Is it a roof, a building? And then what types of GSI or GI are appropriate for that type of use? It's pretty simple, but it helps them just kind of drill in, like, now I know about the few things I'm going to try to think about here. And then the feasibility tool we talked about already also has a process. Again, it's very straightforward, but to give them a checklist of what are the concept plan, preliminary design, final design, and then construction things to be considering, as well as post-construction maintenance. Maybe they received a grant and they want to be able to report to that grantor, just making sure that they're checking all the boxes. So now we've given them the way to evaluate, the way to consider what type of GSI, a process for going through, allowing for review, interdepartmental conversations. If you are hiring a consultant, this can just be a guide for you to say, how do I hire someone? What should I have them follow? If I'm going to write an RFP, request for proposal, because I want to hire a consultant, these are some of the tips of what do you want to ask for? And then we want to help them be able to actually design it. And if you're starting from scratch and you have no idea what the cross section, it's very engineerish here, but what's the cross section of a bioswale? What does that look like? How deep should each section be? What are some specs that go along with that? And then a written specification for the construction packet. So these documents actually were produced in part by us and other partners for one of our clients who is an amazing champion of green infrastructure, and that's Milwaukee's Metropolitan Sewage District. They have offered a lot of these things for free for anyone to use on their website. And we also got permission to modify them to fit the City of Green Bay's specific needs. So some of these details are available. They were in a MicroStation file. We converted them all to Civil 3D and then got them kind of specially honed for Green Bay's use. So it's not, I like to say we're going to be building on the shoulders of giants. It's not reinventing every single time, but learn what's out there, grab up whatever someone else has decided is the best way of doing things, and then build from that point forward so that we're not always spending the same dollars. This was a grant-funded project. It's coming from public dollars. We don't want to waste that, valuable resource. kind of lastly is wrapping these things up. So we don't want to have a document that is like, this thick and you're having to page through page after page and nobody wants to read that. We wanted to have as few real chatty bits of a report and really more about the documents they can get using and move forward with right away. So the actual report is more about attachments of many maps that became the part of their GIS, online GIS platform. And then, those 50 project locations, very easy to take one out of a plan set and say, okay, we're going to march forward with this. And then the really important other piece to that is an operation and maintenance or inspection and maintenance plan. So again, we had another previous project where we put this all together with advice and input from landscapers, landscape architects, designers, contractors all over the country. We had folks from the East and West Coast helping us develop this plan to get a good idea of what's best practices, no matter where you are in the US or elsewhere. And this, again, was done for Milwaukee Metropolitan Sewage District. And they're very generous in saying it was public dollars funded. Let's get it back out into the public and share it as much as we can. So we took that same plan that we developed anyway, and we modified it to fit the city of Green Bay. They had a lot of comments. They wanted to move things around, change out the invasive species list, put in preferred vegetation for native landscaping, a lot of that. So those two plans were prepared. The operations and maintenance plan gives them step-by-step information on each one of the GSI practices that they said they agree with right in the beginning, couple slides. So on each of these types of devices, we have a number of pages of describing what this is. If you have a workforce development group and you want to try to describe to somebody the difference between a rain garden and a bioretention or bioswale device, there's nuances there. So let's give them a couple of cross sections and details and explanations and things. And that's really what this is intended for. Or your public maintenance staff or your private property maintenance staff, whoever they are, let's give them some information on what does porous pavement look like, permeable, porous, pervious, the varieties, why they're called what they are, and what is the typical cross section? Like, is it just pavers like any other paver? No, it's got the subsurface storage area. It's supposed to be a very clean washed stone so water can flow in and be stored there. There shouldn't be clogging happening very often if you're maintaining the surface, because what gets down into the base is, you do the calculations on how many solids are actually deposited there over the course of time. And it takes 30, 40, 50 years to try to start filling up the base of your subsurface area if you're designing it properly. And then what does the maintenance look like? You inspect it every 6 months, you vacuum clean it maybe every 6 months, maybe every year, depends on what's running into that area. So giving them all of those details, again, starting on that shoulder of giants, I'm not going to reinvent any of that, but just package it in a way that people can understand. And then even kind of a marching order of how often do you want to be doing if there's signage, if there's graffiti, if there's trash, how often do you get out there? What's the maintenance indicator when something isn't functioning right? How do you know? Well, if it's trash, you see there's trash. But if it's clogging, you might see standing water on the pavement. So describing what they should see if things are not functioning right, and then what the maintenance is that's required. We describe the maintenance even, what all of those different things mean. And it gives them all the tools. So yes, somebody's going to have to do a little reading in advance, but each of these sections is 5 pages maybe on each type of device that can be pulled out of a binder or a PDF and be able to share with the staff. All of the information then about what maintenance is required for each type of device goes back into that GIS. So the GIS says, on March 1st and September 1st, you need to inspect. You need to, remove trash or whatever the items are that are listed out on here goes into the GIS for someone to produce a report every few months and hand out to the maintenance staff, whether that's done with, your own existing folks, or if you're going to be putting that out to a public bid or whatever. At least you have the information and a tool that will help you generate when do these things have to be done. And really lastly, in our process for this particular project, was to take it to a number of the environmental section of a committee, a couple different committees, a public works committee, a parks committee, and then finally to their common council. And there was a lot of conversation. It did not feel like they were going to approve it right off the bat because people were still going like, that's a lot of money. How do we know there's going to be benefit? We went through a similar presentation to them. They were pretty sold by that triple bottom line analysis. And also somebody from the public happened to show up at that meeting that was fully on board and really supported it and said all of the great benefits that she's gotten out of just native landscaping her yard. And so if you can have a public advocate come to a council meeting, that really does a lot of work to help them approve it. But they approved it unanimously. They gave us a lot of compliments on having a lot of thorough information provided to them. We did a training session for the design process that we talked about for their engineers, construction managers, et cetera. And now the projects are going, out into the CIP schedule and getting into the design process. The really good thing that comes from having a plan like this is it's a pretty, grantors like to see that you have thought through a process, that you have a schedule, and that you really have a reason for placing a GI in the places that you have. If they have grant dollars, you're more likely to be a recipient of those grant dollars when you've gone through a process like that. And so their next step is to start looking for those grants and see what they can get funded through either their stormwater utility or any of the local, especially around the Great Lakes. There's a lot of freshwater grants. This is the end of my presentation. So I'll send it back over to you, Katie.
Thank you so much, Carrie. We got a lot of questions in and we have some time to go over some of them. So we'll get to as many as we can, and any we can't, we'll grab offline. All right, so let's see. Do you have any increased amount of TDS in the porous roadway areas due to the use of salt and calcium for freezing conditions?
We try to encourage using a lot less salt in the areas where there is permeable or porous pavement for the obvious, hopefully obvious reason that when water lands on permeable or porous pavement, it doesn't stay there to become ice. So even when it's snow, once the sun comes out and it melts, it usually infiltrates, and then we don't have that little surface area that will ice up. So a lot less salt is needed in that area. And we also try to place the permeable pavement where it's not going to be as often a salted zone. So for sure in a public parking lot that maybe isn't that utilized during the winter months is kind of like the key locations. A lot of communities are concerned about putting it in the driving lane. Mm-hmm. If it's in the parking lane, it's a little bit out of the area where you're going to have a lot of driving traffic needing a lot of salt. But we've also done something what we felt was kind of creative, and that was line an area where we wanted to store salt and line it and allow for salt storage, salty snow, snowy water, whatever, mm-hmm. to be stored there, and then drain that into the combined sewer in that community. So that water at least isn't going into the groundwater. There's a lot of debate between infiltrating, high salted runoff into groundwater versus running it straight out. But at least it was going to be managed similarly to the other combined sewer roadways.
Sure. Okay. Next, what do you recommend as the most effective means for notice to residents of stakeholder meetings?
I think most people are on the public websites now, or maybe they have a town hall type of Facebook or Instagram page that they can share. That's kind of how we were putting that information out there. We did have a very active social engagement group that was doing door-to-door notices. If you have mm-hmm. a volunteer group, this would happen to be a community health center that was happy to do that. That's also could be effective, especially for older generations that may be not on. I mean, even the old folks now, I think Facebook's become the old people place. So that's just helpful.
All right. This audience member is asking what the TSS removal requirements are for your area. They're in Ontario, Canada, and they require 80%. Although found that some manufacturers can't actually achieve that with their products.
For TSS on typical new development, we're between 40 and 80%. It depends if it's redevelopment, it's 40. If it's brand new development, it's 80. For the city's MS4 permit, it's only 55%. So they're considering the fact that this is already a very built community, and to try to reach 80% would probably not happen. But we have, it's a little bit about how you design the green infrastructure in order to make sure you get that. And for porous pavement specifically, as long as you can allow for soils to infiltrate, raise that under drain up a few feet in your stone storage layer. This is not too much getting in the weeds for everybody. And then you force that infiltration and force the settling to happen. And the only water that's leaving then is what's kind of settled, and the cleaner water is leaving through the under drain.
Got it.
Too far into the details, I'm sure.
No, that was perfect. All right. Are the water quality delineated areas mapped based on land use or water quality sampling data?
They're based on land use. We have this program that is called SLAM, SLAMM. It was produced in mostly, a lot of the data came from field measurements in the 1970s, actually taking samples from roadways, from parking lots, from all the different land uses, and putting them into this model. And so there's 30 or 40 years of actual sampling data that went into that model to develop it. This is a specific Wisconsin model, but I think it's used elsewhere in the country, and there are probably others like it out there. But that way we are designing with the modeling background, and then it's definitely dependent on the land use that we're looking at. And you'll be sort of surprised to find out that a landscaped area offers a whole lot of TSS runoff. So being kind of mindful about your bermed landscape area with mulch, it's all going to run into the roadway. Instead, maybe have a swale as a landscape area, and then you're not contributing that runoff into the roadway. So it goes beyond.
All right, moving along here. Does your city require backflow prevention?
I don't believe that the city of Green Bay does. I couldn't tell you for sure. We are only doing concept level planning. Not backflow prevention for sure on the GI or GSI, potentially at the end of pipe at the riverway. That's a possibility. Then you have maintenance involved in that, and if you don't maintain it, it doesn't work anyway. So we've seen that not be effective, but yeah, I'm not sure about that for Green Bay.
Okay. That same person also is wondering, how are older homes dealing with surcharge conditions and basement flooding in your area?
That is presentation number 2. There's a lot of information that we could give you, but short story, really depends house by house and what the source of that is. If it's coming from 5 or 6 different locations, how it can get into the basement. If it's surcharging through the sanitary sewer, it's more of a public I&I problem, and a standpipe might be needed in your basement.
Okay.
That could be another
This next audience member is asking if you can provide more background on the foreclosed housing GI site selection.
We did not specifically look at home sites that were foreclosed on. We were looking more at larger commercial developments. Maybe it was an old factory that's been closed for many years. So we are looking really at those large places where a lot of funds are going to be spent. So some of the $20 million that we talked about in the construction price, really 40% of that is probably going to be coming from the private side when those properties are redeveloped, if they were equally split. Mm-hmm. And so we're not looking at one single family home type size for this evaluation. We wanted to try to get the largest potential bang for the buck kind of projects out there. And that process really just involved local knowledge of which buildings may be renovated or redeveloped. And if they're going to redevelop anyway, to provide this information to the developer that we're going to need you to do a little bit more in the way of stormwater management. Your regulations are there already for new development. We're adding a little bit of green infrastructure assistance to you in the way of advisement, and then they will also maintain that in the future.
Okay. All right, let's see. What have you seen in terms of maintenance and replacing the biomix materials? How long is required for maintenance, and is that material considered contaminated due to oils, fuels from parking lots?
That question comes up a lot, and we have not seen that be the case anywhere. I think the presence of, going back to like bioremediation and having sunlight and microbes in the soil, sort of generating, and certainly a presence of water being able to degrade those oils and greases and materials, especially for, what we have in public roadways. Not talking about PFAS at all on that subject, but for the specifics of oil and grease. Really, it's going in and replacing mulch, because mulch will be, degrading over time, just replacing mulch, sometimes scarifying the surface of that mix, but not really replacing everything out of the bioswale. The plants do a really good job in keeping that soil loosened as long as the plants are healthy. So it's really more about plant management, invasives management, and, if you have a spot in the bioswale that's ponding long after 72 hours after a storm, then that section might have to be taken out specifically and then replaced. But it hasn't really been a thing that we've seen as a big issue. You would guess that it would be, but it hasn't been.
Yeah. All right. And this is probably going to be our last question. How are maintenance costs annually and over the proposed life cycle that you've seen?
I would have to drill down into every one of these sheets, but we did look at per square foot, what costs that we have seen for porous pavement, bioswale, soils, trees, green roofs, pulled all that information together, again, with sort of a national database, but also really specifically for Green Bay, because they don't have a lot of green infrastructure there. So the costs are actually more because we don't have a lot of players in that area. And so pulled them in a square foot type of arrangement. And then, if we have 200 square feet of a bioswale, it's 200 feet times whatever that dollar per square foot is. And then we just gave it a kind of gut test of, it's $1,000 every 6 months. Does that seem reasonable, or does that seem like what we would expect to hear from a landscape crew out on the site? And so that's kind of how we did that.
Okay. Perfect. Well, that is all of our time for questions today. But Carrie, thank you so much. I really appreciate it. Thanks for sharing all that information with us and answering those questions. For the questions we didn't get to, we will answer those offline. And just a reminder for our audience that at the conclusion of this webinar, you will receive an email with a link to download your certificate for Stormwater University credit or 1 personal development hour. Again, thank you, Carrie, and all of you for joining. We have a short break, and then we have our final closing keynote of the event, a conversation with Gary White. You can join that session by exiting out of this one and going back into the agenda and then selecting that session. So we hope to see you there. Thank you so much.
Thank you, Katie.
Yeah, thank you.